Hey everybody. So I almost ran out of time the last one, so I cut myself off pretty quickly, but let's revisit that last question that we left off on. So looking at letter C, it says find the total distance the squirrel travels. So what I was trying to say is that the problem said this is a velocity graph, and if I really want to know how far he went, I take the antiderivative. Or if I give you miles per hour, like a speed, if I take its antiderivative, I could tell you how many miles you went. If you tell me feet per second, I take the antiderivative, I'll tell you how many feet you went. So if you give me any unit of velocity or any unit of miles per hour, feet per second, anything like that, I take its antiderivative and it tells me how far somebody went. The problem is that with this particular question, there is no function I could take an antiderivative. So in this one, to take its antiderivative, I literally have to measure the area under the curve. So what I was trying to tell you last time is that to find the area in the curve, I'll take the area of this triangle. Up here, I'll have I have a triangle here, I have a triangle here, I have a triangle here. Between these two blue lines, I have a rectangle. Between these two blue lines, I have a trapezoid. And then between these two blue lines, I have a trapezoid. So if I add all these up, I'll get the distance traveled. So for example, here's a triangle, and you know, the area of a triangle is half base times height. Do you see how this base is 4? Do you see how this height is 3? So half base times height, base is 4, height is 3, base times height is 12, half of 12 is 6. So hopefully you guys know how to calculate the area of a triangle. So half base times height is that. This one, a little bit different. This is the first time I'm teaching this, but do you see how this is under the x-axis? So instead of it being a positive number, this is going to be a negative number. And you'll know why, because in this triangle, my height is negative. So look here. My base now is 3, and my height is negative 4. So 3 times negative 4 is negative 12, and then taking half of negative 12 is now negative 6. Okay, so far? And now, are these going to be positive or negative? They're going to be positive because they're above the x-axis. This is the only reason why this is negative, is because it's below the x-axis. So, same thing, area of a triangle. I have a height of 4. I have a base of 3. So this becomes 6. Okay, so height is 4. Base is 3. 12, and half of that is 6. I have a rectangle here. Area of a rectangle is just base times height. So I have a base of 3. I have a height of 4, so this whole rectangle is 12. This is a trapezoid. Actually, I have 2 trapezoids. You may have forgotten how to do it. Remember, it's half or average of the bases times height. So this base is 1. This base is 4. So the average is 2.5. My height is 2. So remember, base 1 is 1, right? Base 2 is 4, so this thing becomes 5, and then half of 5 is 2.5. And then my height is 2, which means this whole trapezoid is 5. Same thing here, except for my height now is 4. I have a height of 1. I have a height of 2. So if I add them, I get 3. The average of 3, or half of 3, is 1.5. Okay, so I have one base of 1, I have one base of 2. If I add them up, I get 3, and half of 3 is 1.5. And then 1.5 times 4 is 6. So if I want to know how far the squirrel went, remember in the problem it's feet per second. So remember, just as important as knowing what the units are. Doing simple addition, you know that these are going to cancel anyway, so I'm not even going to include them. But 6 plus 12 plus 5 plus 6, I got 18, 23, 29. So the answer, going back to C, is going to be the squirrel traveled 29 feet. Alright, more conceptual questions. D says, at what time is the squirrel farthest from building A? How far from building A is the squirrel at that time? Well, remember in our conceptual problem, he went far, like he went 6 feet, and then he came back 6 feet. And then he went up 6 feet. So at this point right here, if you consider these as the area that he went, so he started at some place. Okay, he started at building A. Then he went 6 feet far. But he's like, oh, I forgot my acorn. So he went 6 feet back. Then he had to go 6 feet forward just to get back. Sorry. He starts here at building A. Okay, how about this? He's at building A, he goes 6 feet, and then he comes back to building A. So right here, at this point right here, at 7 seconds, he is back at building A, right? So anything afterwards, since it's all positive, is telling me how far he's been going. So if he went, okay, one last time, sorry. If he went 6 feet far, then came back 6 feet, at this point he's at point 0 again, or he's starting at building A again. So anything afterwards is all positive, or anything here is all walking forward or running forward past building A. So the farthest he is from building A is all the way here at 20, right? He's 6 plus 12 plus 5 plus 6, 18, 23, 29. He's 29 feet away from building A based on the area under the curve. So just to repeat one more time in case you're confused, he ran 6 feet, he came back to the beginning 6 feet, and then from here on was all starting from the beginning and going running forward from building A. So just like letter C, the total distance traveled, or the time that the squirrel is farthest from building A, is 20 seconds, and he is 29 feet. And now that I think about it, this is letter C is a poorly worded question, because it says like the total distance the squirrel travels. I mean, technically, if you think about like how far he's actually walked, I mean, I should add these 12. So I guess I would take two answers. I would take 29 feet, or I would take 41 feet. Because technically he still did travel those 12 feet. It's just that I canceled them out because he went back and forth. But if literally, like, how many steps did he walk? He literally walked 41 feet. In actual movement, he only went 29 feet because he went backwards and forwards. It says that time equals 3 and time equals 11, or 3 seconds, 11 seconds. Find the acceleration of the squirrel, or explain why it does not exist. Alright, it says find acceleration. So remember, this is a velocity graph. How is acceleration related to velocity? Do y'all remember? Acceleration is the derivative of velocity. So literally, the question is asking me, what's the derivative at 3, and what's the derivative at 11? I'll do the easy one first. Look at 11 seconds. You see at 11 seconds I have that corner? So it might have been a while since we've learned this, and it's been months since we learned this, but do you remember when you have a corner, you cannot take the derivative? So at 11, you'll say the acceleration does not exist because the derivative does not exist at 11 seconds. Okay. What about at 3? How do I find the derivative at 3? Remember, derivative on a graph means exact same as slope. So if I want to find the slope at 3, right, here's 3, I want to find the slope, I'll just take the slope formula between 2 and 4, and it'll give me the derivative, or his acceleration at 3. So if I say this coordinate is 4, 0, right, and I'll say this coordinate is 2, 3, I'll just do the slope formula, right? I'll type it out for you. Y2 minus Y1, 0 minus 3, over x2 minus x1, which is 4 minus 2. Okay. So y2 minus y1, 0 minus 3, x2 minus x1, 4 minus 2, which tells me the slope of this is negative 3 over 2, or that is his acceleration at time equals 3, and I'll call it feet per second squared. All right, and then at letter F says at 4.5 is the squirrel speeding up, slowing down, or neither. So I'll look at 4.5. 4.5 is right here. Okay, is he speeding up, slowing down, or neither? So if you want to see it, oh, that's cool. I'll say 4.5 is right here. Is he speeding up, slowing down, or neither? Okay, let's do some examples before you can figure out that answer. See here, he's speeding up, right? It's going up. See here how the slope is going down, but it's still positive. So in this case, the slope is negative but the actual value is positive. So in this case, he's slowing down. But in this segment right here, the value is positive and the slope is positive. So that tells me that he's speeding up. Okay, so here he's speeding up because the value is positive, it's above the x-axis, and the slope is positive. That means he's speeding up. Here, the value is positive, right? It's above the x-axis, but the slope is negative. So this tells me he's slowing down. Here, the slope is negative and the value is negative. Okay? Okay so far? So that tells me, okay, if you can follow along, that he's going backwards very fast. So this means that he is speeding up in the negative direction. Like he's running fast in the opposite direction. Okay? I wonder if that makes sense to you. So if it's positive, if the value is positive, that means he's still going forward. Okay? So in any case where I'm above the x-axis, this line means he's going forward. Anytime the line is below the x-axis, that tells me he's going backward. So this tells me, since it's negative and both negative, that means he's speeding up but going backwards. In this case, in this segment right here, his slope is positive but the value is negative. That tells me he's slowing down backwards, like he's walking backwards but slowing down. Okay? So just to make it clear, here, the value is positive, the slope is positive. He's speeding up and running forward. On this segment right here, the slope is negative and the value is positive, which tells me that he's still running forward, the value is positive, but now slowing down. Alright, here the slope is negative and the value is negative. That means he's running backwards, but really fast. But now here, the slope is positive, the value is still negative. That means he's running backwards, he's starting to slow down, so he could run forward again. Okay? I know that's weird for me modeling for you, but I guess that's only the one way to understand it. So at 4.5, the squirrel is speeding up, but in the negative direction. So you could write he's speeding up in the negative direction because the slope is negative and the value is negative. Okay? And the last one, it says write expressions for the squirrel's acceleration, velocity, and distance for the time interval 14 to 16. So they want me to give an equation for all of them. From 14 to 16, I need to find the equation of a line. So here's my line, right? And it's been a while since you guys had to craft an equation of a line. Okay? So what I'll do is I'll take 2 points. At 16, it's 16, comma 1. And at 14, it's 14, comma 4. So find the equation of a line. It might have been a while. Remember we had to do, here, it's probably better for me to type it out. Remember doing y equals mx plus b? Yeah. So first thing I'm going to find the slope. So I'll do y2 minus y1. So I'll do 1 minus 4 over 16 minus 14. And I will get negative 3 over 2 again. Okay. So that tells me in my equation right here I get negative 3 over 2. So this is back in algebra 1. And then I chose a, if you remember, I chose a x and y, and it helped me solve for b. So if I find x and y, I get to pick any one. Let's do 16 and 1. So I'll do 1 here, and I'll do 16 here. It'll give me what the y-intercept is. So multiplying this out, I get 1 equals, this becomes 8, this becomes 1, so I get negative 24 plus b. Or I get a b of 25. So the equation of this line, just this line right here, his velocity right here is, I know I'm running out of space here, I'll write right here, y equals negative 3 over 2 x, oh, how about this, negative 3 over 2x plus 25. So that's the equation of this line. And that's velocity, right? This is velocity. So the question just asks find, as a matter of fact, I'm going to run out of time again. Find position acceleration. If I want acceleration, I take the derivative of this, which will end up being negative 3 over 2. And then it says find the position. They want you to take the antiderivative. So remember, I add 1 and then divide by it. And then I'm going to make this 25x. So hopefully you guys learn. Do the worksheet that's just like this problem, and I'll get back to you on Monday. Have a good weekend, and I'll see y'all later.